We've got column graphs and we've got dot plots. So let's get into it. A dot plot can be used to display discrete, separate, numerical data, where a dot represents one datum. That's the singular of data, data. A column graph is a way to show data in different categories. So it's useful when more than a few items of data are present. So let's look. Column graphs are drawn either vertically or horizontally. The horizontal column graphs are sometimes called bar graphs. I've heard that before. And so a graph should have the following features. It should have a label on each axis. What are we looking at? Color, number of students, and then the category labels for each of the categories. We should have a title about what the whole thing's about, and we should have an even scale for the numerical axis. So notice this one goes by fives. So if we look at our data, that's going to show us that we don't just want to go by 1 because we've got to go to 20. So fives will do. Any numerical axis must be drawn to scale. So it's got to be evenly laid out. And an outlier is a funny thing. An outlier is a piece of data that's distinct from the main cluster of points. So my favorite outlier is if I took the average age in a classroom, they would be, say, 13, 14, and I would be much, much higher. I hesitate to say what that is. So I would be the outlier if we ever took ages in the classroom. So data represented as a dot plot can be described as symmetrical. So meaning the mean and the median and the mode are pretty much lined up. I mean, that's like totally symmetrical, they're equal. Or they're skewed. So if you're skewed positively, a positive skew means that the mode, the most frequent, is less than the median. So they don't add up, and which is less than the mean. So it means that these measures of center are pushed to the left. Whereas negatively skewed, the mean, the average, is less than the middle point, is less than the most frequent. So you can see when something is skewed. I mean, the word skewed is more important than positive or negative at this point. Symmetrical, but skewed, it's going to slosh one way or the other. So let's look at some examples. So the dot plot below represents the results of a survey that asks how many pets there are. So we've got this properly named, the number of pets, the number of children, and the title for this whole thing, Pets at Home. So what we're looking at, if we look, use the graph to state how many children have 2 pets. So this is the number of children. This is the number of pets. So if I look, this is the number of pets. So if I count 1, 2, 3, 4, that number is 4. Because there's 4 children, because the number of children goes this way, who have 2 pets. How many children participated in the survey? Well, that's easy. I just count all the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and our outlier, 22. So I'm counting the dots. What is the range of values? Well, our highest value is 8, and our lowest value is 0. So my range of values is going to be the highest number minus the lowest number. So that means 8. What is the median number of pets? Now this one gets interesting because I want to find the middle number. So I can count the number of zeros. I don't have enough space. 1, 2, 3, 4, 5. And then I have 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have 4 twos. 1, 2, 1, 2. And then I have 2 threes. 3, 3. And I have 1 and 8. So I'm going to just work my way through and find the middle number there. I think it might be reasonably obvious because I have, what, 22? So if I counted 11 in, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it looks like it could be 1. Let's just check from the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It works out. So the median number of pets is 1. You could also do 1 on the chart, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, knowing that 22 is our total number. What is the outlier? The outlier is 8 because out there by its lonesome, most of the kids, let's do the mode. Most of the kids have 1 pet. How do I know that? Because the number 1 has the most responses to it. That has the biggest chunk of responses. So now this takes a little more time. Draw a column graph to represent the following people's heights. So we have to make some decisions here. So our heights are up to 150, so we want to think we need at least 150 on one side. And how many people we have? 1, 2, 3, 4, 5. So we want to put, I would say, the names of the people here. We want to put the height, and it's important here because we have a number that height is in centimeters. I reckon it makes sense if I'm going to do height to go from 0, and I can do it in 20s. So that's above my highest height. And then for each of these people, so Tim's going to get 1, and each of the other names are going to get 1. Now, of course, yours will be much, much neater. So our dear friend Tim is 150. So that's part way between 140 and 160. So I'm going to use my ruler, which I don't presently have, and I'm going to color in a column for Tim. It is uber sloppy, but I think you get the idea. Now, Philip is 120, so Philip is only going to go as far as this one. Once again, we will fill that in with a ruler and a highlighter. Jessica's a tad taller, so she's at 140, right on the 140 line. Donna is currently enjoying 100. And Nairi is 130, so trying to keep the same distance between 120 and 140. You can lay it out differently, but with the grid I've had, this makes the most sense to go by, sort of by 10s and label by 20s. So there you have an extremely sloppy version of what you will make really pretty. And with a column graph, we want to leave some space in between each set of data.